Good day, everyone. Welcome back. What we're doing today is part 3 of topic 5.1, which deals with multiplying polynomials. The fact that I've broken this topic into 3 sections should tell you how important I feel it is. It's important in terms of building the preliminary skills you need to be successful in algebra throughout the rest of your high school math career. And that algebra that we're learning and we're getting better and better at as every day goes by is algebra that we need to use in trigonometry in grade 11 and 12. It's algebra that we need to learn how to use so that we can be successful in the next unit in this course. It's algebra that we will see again and again and again. So this isn't just a unit about a specific set of skills that we can learn and then forget about and say we're done with them. This is something we're going to need continually. And it's important that we get lots of practice and we get better and better at it. One final comment before we get the ball rolling today. I've said this before. I will mention it now again. Your goal in working with some of these topics in math, particularly algebra, is that you are better at completing the problems. Your skills have improved compared to what they were like earlier. So at the end of this lesson, you should be able to look back at, say, example 1 or 2 and go, oh, that's easy now. And you should be able to look back at the work we did yesterday and the day before and go, that's really simple. You're always trying to get better and better at doing the math. So what we're looking at today is continuing to multiply polynomials, but we're going to add 2 other mathematical operations, which are addition and subtraction. And I just want to remind everybody of what we call BEDMAS in our school system. It's a goofy word, but it means that you always simplify things that are in brackets, and then you apply any exponents, and then and only then, after you've done the work inside the brackets and you've applied any exponents, then you can worry about division and multiplication. And the order of division and multiplication doesn't matter. You can do multiplication first, then division. And then you can do addition and subtraction. And since addition and subtraction are really the same thing, because subtraction is just adding negative things, the order in which you do them doesn't matter. What's going to happen in the problems we look at today is there's going to involve multiplication and then addition and subtraction. We won't really have anything where we have brackets that we simplify what's inside. And exponents in this particular lesson are simply going to be written as multiplication. And you'll see that in action here in a minute. So the first question says simplify, and we have 4 multiplied by x minus 1 plus 3 multiplied by x minus 3. So if you look at the brackets, if you look at what's inside of the brackets, for example, if we just take a peek at x minus 1, we can't simplify x minus 1. You can't take 1 away from x. They're different kinds of things. And the same can be applied, or the same reasoning can be applied to x minus 3. There's nothing to simplify in the brackets. So what we're doing is we're jumping all the way in our order of operations to multiplication. We know that when you multiply 4 by a binomial, you use the distributive property. We know that when we multiply 3, which happens to be a monomial, by a binomial, you use the distributive property. This is really what I would describe as a simple 2-step problem. When we multiply 4 by x, we get 4x. When we multiply 4 by -1, you get -4. Now I'm going to pause for a second, and I want you to notice that in the question, in the brackets, it says x minus 1. But when I did the multiplication, I thought of it as 4 multiplied by -1. So that -1 in the brackets, when I do multiplication, I think of that minus as a negative, and that negative is glued onto that 1. Similarly, when I take 3 times x, I get 3x. And then I take 3 multiplied by -3, and I get -9. So my first step is simply to multiply 4 by x minus 1 and get 4x minus 4. and 3 by x minus 3 and get 3x minus 9. Now I do have some things that can be added together. 4x and 3x are things that are the same types of things. It's like taking $4 plus $3. You get $7. Similarly, negative 4 and negative 9 are things that can be added together. Negative 4 plus negative 9 is negative 13. So my final answer when I put all these ideas together is 4x plus 3x is 7x, and then I have negative 4 plus negative 9, which is negative 13. Briefly here, my hope, everybody, is that you don't need a calculator for every single calculation. My hope is that everybody can figure out that 4x plus 3x is 7x, and that everybody knows that negative 4 plus negative 9, or negative 4 minus 9, if you like, is negative 13. However, that being said, I understand that some people struggle with their what we call basic math facts, which is how to multiply numbers together or how to add or subtract integers. So even though my hope is you don't need a calculator, for goodness sake, if you need to use a calculator to get the correct answer at this final line, do so. Don't sit there and wrap numbers around in your head and end up with an answer that's not right. If you're unsure, check with a calculator. So that's the answer to 1. 2, same kind of thing. I'm going to rewrite it, and I wouldn't normally rewrite it, but I want to talk a little bit about this second part. We have 3 times x minus 5, and then it's minus 9 times 2x plus 1. And I'm saying that you should think of that negative as being attached to that 9. I think of this as 3 times x minus 5 plus negative 9 times 2x minus 1. So I multiply this 3 by the binomial and get 3x minus 15, because 3 times negative 5 is negative 15. And then I can say the negative 9 times the 2 is negative 18x. And the negative 9 times the 1 is negative 9. And, you know, in retrospect, looking at what I wrote in the first line here, I'm not really sure that this positive sign that I'm about to erase is needed. In fact, looking at it in retrospect, I think it might have been confusing to write that. The bottom line is that minus is attached to the 9. So negative 9 times 2x is negative 18x, and negative 9 times 1 is negative 9. Now we can bring these terms together. 3x minus 18x gives us negative 15x. So that's what happens when we add these two terms together. You'll notice, you might notice, most of the time I will say we're adding things together. In reality, we're taking 3x minus 18x, which is the same as 3x plus negative 18x. And then negative 15 minus 9, those two terms can be combined as well. And I get negative 24. So my answer to this question is negative 15x minus 24. Now I said I would show you an alternate way to do this. I'm thinking ahead here, and I'm thinking that this is not the best question or the best place to do so. So I'm going to leave it here. Next question. We have 2a times 2a minus 4. Well, that's a product. That's a multiplication. Plus 8a times 3a minus 1. Well, we have to do all the multiplication first. So we're going to take the 2a and multiply it by the 2a. And we're going to take the 2a and multiply it by the negative 4. Okay, 2a times 2a. Well, 2 times 2 is 4, and a times a is a squared. And then 2a times negative 4. Negative 4 times 2 is negative 8. And of course, we're going to have the a. 8a times 3a needs to be accomplished, and 8a times negative 1 needs to be accomplished. So 8a times 3a, well, 8 times 3 is 24. A times a is a squared. And then 8a times negative 1 is negative 8a. 8 times negative 1 is negative 8, and then we have an a. We can combine some terms together. These are a squareds. These are a squareds. We have 4a squareds plus 24a squareds, which is 28a squareds. This and this, these are like terms. Be careful, some students will look at those two terms and go, oh, we get nothing. We don't get nothing. Negative 8a plus negative 8a is negative 16a. So our final answer is 28a squared. I'm just double checking my multiplication. Minus 16a. Number 4. Well, we have to do multiplication before we do addition or subtraction. So we are going to have to multiply the y plus z by the y plus 5z. And we are also going to have to multiply y minus 3z by y minus 3z. Don't forget, I've told you that anytime you have a binomial, I'll just say a plus b quantity squared. That means you have to multiply out a plus b times a plus b. As far as you're concerned, there is no shortcut to getting the square of a binomial. We may talk about one later, but for the time being, you have to do it that way. You have to write out the binomial multiplied by itself. So again, according to the order of operations, you have to do multiplication before you do addition or subtraction. And by the way, inside each of these 4 sets of brackets, there's nothing to be simplified. So I'm going to apply FOIL here, F-O-I-L. Y times y is the first, which will be y squared. Y times 5z is the outer, so that's 5yz. My inner is z times y, that's yz. We tend to write the variables, the letters, in alphabetical order. And then the last is z times 5z, which is 5z squared. Now, in the previous question, I was going to show you, maybe not the previous one, maybe the one before. I was going to show you an alternate way to do something, and I decided to save it to here. So let's just continue with this, and then I will explain to you what I mean. We subtract now, and I have to apply FOIL here. I need to take first, outer, inner, and last to these two binomials being multiplied. So first is y times y, which is y squared. Outer is y times negative 3z. Well, that gives me a coefficient of negative 3, and I have the variables of yz. My inner happens to give me as well negative 3yz, because I'm multiplying negative 3z times y on the inside. And my last, a negative times a negative, negative 3 times negative 3 is positive 9, and I have z squared. Now, I want to stop right here and tell you that there is a fatal algebraic mistake that students make all the way through high school. I have students in Math 30-1 and in Calculus sometimes making this mistake. And it's too bad that the mistake has to do with something from grade 9 and 10, and then when you get to grade 12, you make the mistake, you make a grade 9 or 10 error, but that prevents you from getting the right answer in grade 12. We've talked about this before, how math is very foundational. Everything we learn, you carry with you to the next level. The thing that is wrong with what I have written here is that the fact of the matter is this subtraction sign, really important. Think about this. This subtraction sign applies to this whole thing. We have to subtract that whole thing. We're not just subtracting part of it, we're subtracting the whole thing. And we accomplish that on paper by putting a set of brackets around the entire thing. So we're not just going to subtract the first. We're going to subtract the first, we're going to subtract the outer, we're going to subtract the inner, we're going to subtract the last. So how do we proceed from here? Well, we can clean this up a little bit. We have y squared, and this is 6yz because we have 5yz plus 1yz. We also have 5z squared. Now, there are a lot of numbers and letters flying around in this stuff. You need to slow down and be organized in your thought. All right, and then it's minus. Now, before I deal with the subtraction, I notice that inside of these brackets, I have two terms that can be combined. So I'm going to leave the brackets alone. I'm going to write negative 6yz for those two terms, leave everything else alone. And now I will worry about subtraction. Now there's two ways you can proceed here. Let me show you what I like to do. I have y squared plus 6yz plus 5z squared. I am going to subtract y squared. I am going to subtract negative 6yz. And when you subtract the negative, it becomes a positive. And I am going to subtract 9z squared. Now that's just what I prefer to do. There's absolutely nothing wrong with you imagining that, well, you don't have to imagine because it is in fact the case, that there is a coefficient in front of that set of brackets of negative 1. And when you multiply negative 1 by y squared, you get the negative y squared. When you multiply negative 1 by negative 6yz, you get positive 6yz. And when you multiply negative 1 by 9z squared, you get negative 9z squared. Now what we can do is we can combine all of our like terms, just taking them and highlighting them for you. We have these two terms which are similar. We have these two terms which are similar. And we have these two terms which are similar. Terms are similar if the variables are the same. So looking at the yellow terms, y squared minus y squared is 0. We don't need to write that. The green terms, I have 6yz's plus 6yz's, no different than 6 cheeseburgers plus 6 cheeseburgers. I get 12 of them, except of course they are not cheeseburgers, they are yz's. And then the blue, 5z squared minus 9z squared, 5 minus 9 is negative 4z squared. And that's our answer to this question. All right, we have 2x plus 1, and we are subtracting 7x times x plus 3 times 2x minus 1. Now I haven't done anything, I've just rewritten it because I just need a little more space to explain something. We are actually multiplying three things together here. We are multiplying the negative 7x by the x plus 3 by the 2x minus 1. And I've talked about this in a previous lesson. Part of me wants to say that it was in the last lesson, that when you have three things being multiplied together, and I always use the numbers of 2, 3, and 4, you're going to get 24, and you can get it by multiplying these two together first and getting 12, and then multiplying the 12 by 2. Or you can multiply the 2 and the 3 together to get 6, and then multiply by 4 to get 24. You can multiply the 2 by the 4 to get 8, and 8 times 3 is 24. So these three colored pieces that I have to multiply together, I always prefer to multiply this together first. So this will be first, which will be 2x squared. Outer is negative x. X times negative 1. Inner is positive 6x. And last is negative 3. And I'm going to put these two together now. I get 2x squared plus 5x minus 3. And I'm really hoping, everybody, that to go from here to here, which was a struggle 2 days ago, should be what I refer to as child's play. It's very simple. First is x times 2x, which is 2x squared. Outer is x times negative 1, which gives you negative 1x or negative x. Inner is 3 times 2x, which is 6x. And last is 3 times negative 1, which is negative 3. And you put the x's together. This, I don't mean to put undue pressure on you, but this is a 10 to 20 second task. Now, let's write in the rest of the question. We also have 2x plus 1, and we are subtracting 7x multiplied by that. So I am going to make sure that when I multiply, I'm multiplying negative. I'm just going to move that negative over a bit more in front of the 7. Make sure that I'm multiplying the negative 7x by what's inside. So I have my 2x plus 1. We really don't need those brackets around the 2x plus 1. Negative 7x times 2x squared will give me negative 14. 7 times 2 is 14, and it's negative, and now we'll have x cubed. Negative 7x times 5x gives me negative 35, and I will have an x squared. Negative 7x times negative 3 gives me positive 21, and I have an x. Now I have to take that 2x plus 1 and combine it with all those other terms. So highlighting terms that can be combined together. The x's can be combined together. And that's it. The 1 has no variables. There's no other terms in this whole line of algebra that have no variables. This term has x cubeds. There's no other x cubeds in there. And this term, horrible combination of colors, that term contains x squareds, and there are no other terms with x squared. So typically when you write out a string of polynomial terms like this, you put the term with the highest exponent on x first, then the next smallest, or next highest rather, and then you keep decreasing. Now, what are my x's? 2x plus 21x is 23x. And then I also have plus 1. So I end up with negative 14x cubed minus 35x squared plus 23x plus 1, and that's the answer. I'm going to do one final example. Look, there's nothing new about this example. They're just getting progressively and progressively more difficult. The idea is, as I might have said earlier, what we are doing is we are flexing those math muscles here. We're trying to get more and more skilled at this. I would always recommend that when you have 3 things multiplied together like this, that you multiply the algebraic binomials first. Then worry about multiplying by whatever's in front. So I have negative 3, and I'm going to FOIL out what I've underlined here. X times 2x is 2x squared. X times 3y is 3xy. Negative y times 2x will be a negative, and I have a 2 and an x and a y. And then negative y times positive 3y will be a negative 3, and I will have a y squared. Then I have minus 7. And I'm going to FOIL out that. X times 2x is 2x squared. X times negative 6y would give us a negative 6, and then an x and a y. 3y times 2x, well, 3 times 2 is 6, and then I have an x and a y. And then 3y times negative 6y, 3 times negative 6 is negative 18, and I have a y squared. And I am going to pause here and do what I would recommend you do when you're working on things, which is to double check all of your products. It only takes a minute, and we want to make sure we get the right answer. So these two multiplied together give me 2x squared. Then I go to my outer. These two multiplied together give me 3xy. I look at my inner here. It gives me negative 2xy, which is correct. That's what I wrote down. And my last will be negative 3y squared. Going over here, my first is 2x squared. Correct. My second, or my outer rather, is x times negative 6y, which gives me negative 6 with an x and a y. My inner gives me a positive 6y, and my last is negative 18y squared. Don't forget, BEDMAS says simplify what's in brackets. Well, we couldn't simplify any of the stuff in the brackets to begin with, but we can now. All right, these two things can be combined together, and these two things can be combined together. So I have my negative 3, then I have 2x squared plus 1xy. 3 apples minus 2 apples is 1 apple. Minus 3y squared. Then I have a negative 7, and in brackets I have 2x squared plus nothing. Negative 6xy plus 6xy is 0xy. I mean, look, if you want to put an xy here, you certainly can, but you don't need to. And then, of course, we have our negative 18y squared. All right, this gives us negative 6x squared. Negative 3 times 1 is negative 3xy. Negative 3 times negative 3 gives me positive 9, and I have y squareds. Multiplying the negative 7 through, negative 14x squared. And negative 7 times negative 18y squared will be positive. I want to say it's 126. Pretty confident on that. You can double check it yourself, but it's 126. Now I can combine the x squareds together. I have some x squareds here and here. If I look at my xy's, these are the only xy's. And then, of course, I have y squareds that I can combine together. Let's see. What do I get? Negative 6x squared and negative 14x squared is negative 20x squared. Think of the negative as being a debt, and think of the x squareds as being dollars. I owe $6 because it's negative $6. I owe $14 because it's negative 14. So if I owe you $6 and I also owe you 14, then I owe you 20. I have my negative 3xy, and then my y squareds, 9y squared plus 126y squared is 135y squared. And that is our answer to this question. Lots of practice here. Remember, your goal is to sit down and get started with this, and after you do a couple of problems and you start the third one, hopefully you look at the third one and you go, oh, this, I know how to do this. I've just done a couple like this. And at the end of maybe a half hour of working with this stuff, you're going to say the same thing in general. You're going to say, I'm much better at this now than I was half an hour ago. If you want my advice for how to get better at this kind of math, it's that you need practice daily and not just a bit of practice. You don't do one question and then get distracted and move on to something else in your life, and then go back and do another question and repeat that process. What you need to do is sit down, put your phone away, get rid of any distractions, and start doing some math, working at it for a half hour at a time. Anyway, I hope that made sense, and I hope that you're doing well. Looking forward to seeing you soon. Take care.